All right, so we're going to continue on what we were doing last time. If you remember, we talked about logit model, and that model is a mode split model. Okay, now on logit model, we said that we use this formula, that probability of individual person choosing a mode of transportation M is equal to e to the power of u sub m over summation of e to the power of u sub k. K, which is the number of modes, is equal to 1 to n. Depends on how many you have. And then I show you what the utility function is. It's a linear function. I gave you an example. And on that example that I gave you, we calculated if you remember, we calculate u sub a, utility of a, we calculated, and it was minus 0.625. And then we found the probability of a, which is probability of a person choosing a mode of transportation by auto, was 0.71. We did that problem last time. And then we said that utility of a bus, when we calculate them, was minus 1.53. When we put them into our model, we calculate probability of B, or going with the bus, was 0.29. So the summation of these two probabilities are equal to 1. So this is as far as we went. Now, if I tell you that there are 5,000 trips, so if I say the volume of the trips are 5,000 trips, okay? If that's the volume, how many are going with the auto? How many going with the bus? So we just say 5,000 trips that going, 71% going by auto, so that's 0.71. So that means the number that go by auto is 3,550 trips per day. So 5,000 trips, 3,550 going by automobile. And then by buses, 29% going. So we get the 1,450 trips per day, correct? So that's how we do that, and that's where we use them. Now, if I tell you that people pay the fare, bus fare, is 50 cents per ride, let's say. And what would be the revenue? So we have 1,450 trips by bus times 50 cents, correct? So the revenue, that's the amount of money that the bus receive, is $725 per day, correct? Okay, so that will be the revenue. Any question on this? All right. Now, let's assume that there is another mode of transportation that we add, such as rapid transit, like a metro. If we do that, what will happen? Well, let's see what happens. If I have another mode of transportation we call rapid transit, and I gave all the x's for rapid transit. You remember we had x1, x2, x3, x4. So your utility function was, if you remember, um was equal to q, was equal to am minus 0.025 x1, okay, minus 0.032 minus 0.05 x3 minus 0.002 x4. Okay, so that's use of m. Now, if I say that we apply another mode of transportation, so we had so far auto, bus. So I want to have auto, bus, and I want to introduce another one we call rapid transit. So we had the information of x1, x2, x3, x4 for auto and bus. So if I give you information for rapid transit, and I say for rapid transit, your AM is equal to minus 0.06. If I say that's your AM, and I put your X1 as a number, which is X1 will be 10. X2 for rapid transit, if I say X2 is equal to 5, and X3 for rapid transit is equal to 30, and X4 for rapid transit is equal to 75. If I give you that information, so now I want you to find what would be the use of rapid transit. So to find the use of rapid transit, what do? We put the AM 0.0 minus 0.06. X1 you put 10. X2 you put 5. X3 you put 30. And X4 you put 75. Okay, and then you do that calculation. So then utility of rapid transit is going to be equal to, after you multiply these numbers and add and subtract, utility of rapid transit will be minus 1.070. So that will be utility. Now, how do we find the probabilities? So I will say that probability of individual person I using rapid transit is equal to, okay, e to the power of minus 1.070. That's the rapid transit utility, divided by the summation of the modes. So how many modes do we have? We have 3 of them. we already got the use of A, which was minus 0.625 plus e to the power of the utility of a bus, which was minus 1.53 plus utility of rapid transit, which was e to the power of minus 1.070. So when we calculate that, because we have three modes of transportation, when we calculate this, the probability rapid transit will be 0.313. Okay, everybody understand that? Now remember, if that's the case, utility of bus and auto will change. Because if I want to get the auto, what do? I change this number to 0.625 and I calculate that. So that will be 0.489. So this is for auto. This is for rapid transit. Now I have to get the bus. Let's say I will get the bus, and then the bus, I replace that number by the utility of a bus, which is minus 1.53. So if I do that, the share of the bus will be 0.198. So this is for bus. So if you add these together, you will have 1. So that means 19.8% using bus, 48.9% using auto, and 31.3% using rapid transit. So by introducing the third mode, that would happen. The third mode takes some of the answer, because before, when we had only 2 for a bus, if you remember, we had 0.29. And here we had 0.71. Now, when we introduce the rapid transit, a lot of people who are using auto, okay, almost 22% of them going to rapid transit, and some of the buses going to rapid transit. Now, to figure out how many goes by rapid transit, how many goes by auto, so we will find the QA, which is the volume. So the volume of auto is equal to 5,000 times 0.489. And that give you a number of 2445. So the volume by bus will be 5,000 times 0.198. And that give you the number of people who are using bus, 990. And the number that using rapid transit would be 5,000 times 0.313. And that give you an answer of 1565. So if you add all of these, will be 5,000. So we had the split between the different mode of transportation, and these are the volumes. Okay, any question? Now, if I say that how much money rapid transit revenue will be, no, the mass transit revenue will be. Mass transit means what? Means buses and rapid transit. So for buses, we had 50 cents, correct? Per ride. And if I give you the rapid transit at 75 cents, so you calculate those two numbers and that numbers, and when you calculate that and you calculate this, okay, so the total will be 2585. Actually, no, it will be 1668. I'm sorry, 1668. Okay. So that means $1,668 will be collected by mass transit. That's the revenue. Okay, any question on this logit model? So we did it with 2 modes of transportation. We did it with 3 modes of transportation. If you have more modes of transportation, the same way you do it.
Professor, these equations are in the book?
No, it's not. Actually, your logit model is not in your book.
Oh, okay. Thanks.
The only equation you need is that e to the power of um divided by e to the power of uk summation. That's all.
What about the UM equation? Is that going to change, or is that
Oh,
always?
this changes.
So that would be given if you
This will
if it was on a
change.
test?
Yeah. This will change. So most of the time in the problem when you have it, they give you this.
Oh, okay. Thank you.
And they give you all the x's and so on. All you have to do is just replace them to get your utility. That's all. And then put them into the logit model. Yeah, all this, when you are taking the data in a zone and you calibrate all those coefficient changes. So you estimate your equation or calibrate them, but we don't get involved that much. If I give you a problem like this, I will give you that equation, I give you all the x's and am. All you have to do is just replace them, calculate what's the use of A is, what's the use of buses, what's the use of rapid transit is, and put them into this equation here. Okay, and then calculate the probabilities. And if I give you total volume, you can figure out how many cars going, how many rides going by auto or rapid transit, and so on. Yeah. All right. Anybody else had a question?
Professor, um, when the answer is 8, where'd you get?
Pardon? I didn't get your question. What's the question? I don't hear anything.
My Wi-Fi is unstable. Get the 0 point for the last part.
The last part? I don't understand what you're asking for.
Yeah, when you solve 68, 75.
Oh, it says 75 cents per ride for rapid transit, 50 cents per ride for a bus. And those are the number of people who are using it. So you multiply by that to see what would be the total. For this one would be, for instance, $445. And the other one you have to calculate, the total will be 1668. Does that answer your question? These will be given to you. So we give you these numbers. Okay? Any other question? Okay, so this is the mode choice. And this is the example that you should review it and see how you can do it. All right, the next thing we want to talk about is the assignment model. So what we have done so far, okay, this is what we did. We have, let's say, a development. We had a trip generation. We did it by method of cross classification or ITE, trip generation manual, or regression analysis. We found out that, for instance, how many trips is generated by this development? Let's say 1,000. The next thing we did was the trip distribution. We tried to figure out how many going in each of the different zones, correct? So we figured out those by gravity model, manual model, freighter model. So that was the trip distribution. Now that we found, for instance, out of 1,500 going this way, now we want to know which mode of transportation they take. By mode choice, we find out, for instance, that 500, maybe so many going by bus, so many going by metro, so many going by auto, and so on. So that's a mode split. Now, the ones that use auto, they got to go to streets. So they have to go through these network of streets to get there. Okay? For instance, when you come from home to Cal State, LA, there are a bunch of streets that you use, correct? To come. So we want to know which street you use. For instance, if you are using this street, then your trip will be added to these streets. If you are using other street, your trip will be added to the other streets. So that's what we call assignment model. We have to assign your trip to one of these streets. And remember the first homework problem that you did, minimum travel time path? If you're assuming that everyone using the minimum travel time path to go from one point to another point, so we just assign those trips over the minimum travel time path. So if the minimum travel time path you calculate on this network is this, so that means your trip will be added over that network, and so on. And then we have to add your trip to existing volume to see if that causes congestion or not. If it does, then we have to come up with some solution. So we have to do the assignment model, assigning the trip to the network. There's two types of a method that we're going to use, and one is called diversion curve, and the other one is called all or nothing assignment model. On the diversion curve, okay, what we want to do is we want to figure out the time ratio as the x-axis. What's the time ratios? Time via freeway over time via quickest road. So we get this time ratio. For instance, if you use the freeway, if it takes you 10 minutes, and if you use the quickest road and it takes you 5 minutes, then the ratio is 2, or vice versa. So you get that time ratio. And then here you get the vehicle using number of vehicle using. So you do vehicle using freeway over vehicle using all routes. This is your y-axis. So there is a curve such as this. And if the time ratio is equal to 1, that means 50% of the people using freeway. Okay? 50% using other routes. Because they are both the same time. So if you go from home to school, if you use freeway, it takes you 10 minutes. If you use the quickest route, it takes 10 minutes. 50% of the people using quickest route, 50% of the people using freeway because they are the same. If the right time ratio of freeway gets more than quickest route, then less percentages using freeway. And vice versa. If the freeway give you faster than quickest route, so the number will be, if this is the 1, will be less than 1, so it will be more usage of freeway. So this is what we call diversion curve. So diversion curve, it just split the trips between freeway and quickest route. So that's the diversion curve. Any question on that?
No.
All right. The next thing that we want to do, we want to use all or nothing assignment model. Okay, so this is what we call all or nothing assignment model. That's what you want to do. So the first one is we want to find the minimum path tree. Find minimum time path tree from each of the zone centroid node to all other nodes. That's the first step. The second step, assign the flow from each origin to each destination. Node obtain from the trip table. The third, sum the volume on each link to obtain the total volume. Okay, so these are the 3 steps that we have to do. Okay, now to do these 3 steps, I have to give you an example of how to do that. Okay, and here is the example I can give you. I give you an example. Let me go to the next page. Any question on these 3 steps? Okay, I'm going to go to the next page to give you an example. Let's say we have 4 zones. Okay, we have 4 zones. And this is zone number 1, number 2, number 3, and 4. So when you go from 1 to 2 in that direction, it takes you 11 minutes. If you go from 2 to 1 in that direction, it takes you 10 minutes. If you go from 2 to 3 in that direction, it takes you 7 minutes. If you go from 3 to 2 in that direction, it takes you 5 minutes. And here from 3 to 4, it takes you 6 minutes. And from 4 to 3, it takes you 10 minutes. And then it will take you 8 minutes this way, and it takes you 7 minutes this way. Okay? Everybody understand that? The 2 ways, like 2-way street. From 1 to 2, it takes you 11 minutes. From 2, you want to go to 1, it takes you 10 minutes. If you go from 2 to 3, it takes you 7 minutes. But if you go from 3 to 2, it takes you 5 minutes, and so on. And then I give you a trip table. So from node number 1, 2, and 3, and 4, and here is node 1, 2, 3, and 4. These are the nodes. All right. So from 1 to 1, there's no trip. From 1 to 2, you get 500. From 1 to 3, you get 750. So you get 350 on 4. And then you have 275. And you get 0, 2 to 2. 2 to 3 is 1050. And then you have 475. And then you get 650. You get 1870. And then you get 0. And you get 950. And you get 1250. okay? And you get 350, and you get 2050, and then you get 0. So this is what we call origin destination table. So these are the volumes, which is vehicle per hour. So the first question I have, where do you get that table from? Where does that table come from?
Is
Does everyone listen? Where are these numbers come from?
there are they the amount of people that travel through zone 1 or 2, 1, 3?
But what model give you this? All the model that we talk about. Where is this come from? Which model? Which model give you the number of the trips that go from one zone to another zone?
Is it the fracture model? Growth model?
Trip distribution model. Yeah, trip distribution model, like gravity model, freighter model that you're working on. At the end, it give you how many trips go from one zone to another zone. So this trip table come from trip distribution. Now that we have it from trip distribution, we want to assign it over our network. So if you remember the last page, I said the first step is find the minimum path tree from each of the zone centroid to all other nodes. So we have to find minimum travel time path. So we can use the algorithm that we learned for the first problem that we did, that network problem. But here is very simple. So we can just observe it. Otherwise, we have to do it through algorithm. So the first one from zone number, I will write here, home node number 1. From zone number 1, what would be the 3? Minimum travel time path. So which way do I go to get from 1 to 2, which is the least? Well, if I have this node, which is 0 minutes, that's the node number 1. My 3 to node 2 will be what? 11 minutes, correct? That's the minimum, because any other way you go, it's longer. So how do I get from 1 to 3? How long does it take the minimum to go from 1 to 3?
18?
Okay. 18? Do you have anything less than 18?
13 if you go from 1 to 4 and then to 3.
Yeah, so that's 17, correct? So you have to go here, and then you have to go here, right? And it takes you 17 minutes. And you have to put these arrows that show you the direction. Then from 1 to 4, it seemed like 7 minutes is the one that controls, right? So that give you the 3 from node number 1. Step number 1 set from each node to all other nodes. So we had to do number 2. So home node number 2 is here. That's the 0 minutes, correct? So what's the fastest to get to 1?
The
10?
10 minutes.
10 minutes, correct? So I have to go this way. So get to node number 1, and that's 10 minutes. Now, how do I get to 3? So it seems like this one controls, correct? So that takes you what, 7 minutes? And then to go to 4, I can go two-way, take the 10 and 7, which is 17, or go the other way, which is 7 and 6 is 13, right? So I use the 13. So I go use this here. So this is my network for, or tree for node number 2. For node number 3, I am here at 0. So I want to go to node number 1. To go to node number 1, what's the best way to go?
Go up 2 and then 10. Be 15.
There's other way.
To go to
The 6, go to 4, yeah, go to 4 1.
Yeah, so you have to go to 4, and then you go to 1, correct? And that takes you 14 minutes. So you want to find the minimum. Now to go to 2,
13 minutes, Professor. Oh, no,
okay?
never mind.
So this would be what? This would be 5 minutes, correct? And then from 3, you go to 4, it takes you 6 minutes, correct? So that's the 3 from 3 to 4, from 3 to all other nodes. Then you go to 4. So 4, you're here, 0 minutes. You go to 1, it takes you 8 minutes, correct? You go to 2, it takes you 15 minutes, which is this way. And you go to number 3, it takes you 10 minutes. So we got from all nodes to all other nodes, minimum travel time path, right? Everybody understand that? So on the homework problem that you did, that network problem, you went from one node to all other nodes. But if you had to do this network or that network, you have to do that problem 24 times because you got to do from, you had 24 nodes. So you have to do from each node to all other nodes and find the trees. And if you have 100 nodes, then you have to do 100 times. That's why we need computer to do it. All right, now that you did this, what's the second step telling us to do? You say assign the flow from each origin to each destination. Okay. So what we have to do here is we have to assign from node number 1 to all other nodes. So 1 to 1 is 0 on that table. 1 to 2, it says 500 trips. So we have to use 500 trips to go from 1 to 2. From 1 to 2 is this here. So we go 500 trips here, correct? Now we have to go from 1 to 3. Okay, pay attention to this one. If you want to go from 1, which is right here, to 3, which is right there, 750 trips it shows. But if I want to go from 1 to 3, I have to come to 4 and then go to 3. That's the way I'm supposed to go. So 750 trip will be on this link. Go to 4, and then 750 will be on this link, continuing to go to 3. Everybody understand that? So you have to use the street that go from 1 to 4, all 750 trip that want to go to 3. Okay, now let's assign the 1 to 4. Now from 1, I want to go to 4. It's a 350. So I have to add 350 to it, correct? So another 350 will be on this link. Everybody understand that? Okay, now let's go to this node number 2. From 2, I have to go to 1, 275. This is 2, this is 1. 275 will be on this link. 2 to 2 is 0. 2 to 3 is 1050. From 2 to 3 is 1050. So 1050 will be on this link. And from 2, I have to go to 4. 475. The same situation. I have to go to 3 and then go to 4. So there will be 475 added to this link. And then another 475 here. Now from node number 3, I have to go to 1. So node number 3, I have to go to 1, which is right here. So again, I have to use 650 to go to 4. And 650, I go to here. Now from 3, I have to go to 2. So that's at 1870, 1870. And from 2 to 4 is 950. So another 950 here. So I'm assigning the trips over my network. And the last one from 4 to 1 is 1250. This is 4, this is 1, 1250. 4 to 2, 350. So 350 has to go here. 350 has to go here. And then 4 to 3. 4 to 3, I have to add 2050 to it, correct? So I assign the trips over my network, correct? Anybody has a question on this? Okay, now let's see the third step said add up these. Okay, so I'm going to do this. I'm going to go from 1 to 2. Let's see how many trips will be there. There is from 1 to 2. There is 500. 275 is the opposite direction. I don't care about that. There's nothing on the third node, nothing on the fourth node. So there's only 500. So I'll put 500 here. Now going from 2 to 1, 500 is the opposite direction. 275 is there from 2 to 1. Nothing on the node number 3 and 4. So 275. Everybody get that? All right, how about 2 to 3? I have to go 2 to 3. How many trips will be there? Okay, let's look at this one. There's nothing here. Nothing there. But from 2 to 3, I have 1050 plus 475, which is giving you what? 1525. This is the opposite direction. And this is the opposite direction. We don't care about those. So 1525 is the answer. Now the opposite direction, going from 3 to 2. From 3 to 2, nothing there. This is nothing because it goes the opposite direction. But here is 1870 going in the right direction and 350 on the right direction. So I have to add these two. If I add these two, will be what? 2220? Okay, 2220. Everybody get that? Now the next one is from 3 to 4. So from 3 to 4, again, this is the opposite direction. We don't care. But from 3 to 4 is this one. 475. And then we have these two volumes. So 650 and 950 will give you 1600. Plus 475 is give you 2075. All right, everybody get that? Now from 4 to 3, the opposite direction, 4 to 3. So there is 750 here, and this amount here. So 2050 and 350 is 2400. And 750, it give you 3150. Now we go from 4 to 1. From 4, we go to 1. So there's 650 and 1250. So that give you what? 1900. And from 1 to 4, hold on. From 4 to 1, 1250 and 650 is 1900. That's right. And from 1 to 4 will be only 350, correct? Okay. Any question on that? No, there should be something wrong here. Hold on. Oh, here is. Yeah. Okay, let me use yellow. So you have this one. 750 and 350 is 1100. Okay, so you have 1100 here. All right. Any question on that? So that was the third step. So we did all that summation. Any question on this?
What is this called?
This is assignment model. We are assigning the trips over our network. So you got to follow those 3 steps.
Okay.
To do it. Okay. Any other question? Is that clear to everyone?
Yeah, it's clear.
Okay, you got to practice this. Make sure that you understand how to do it, because on the exam or a quiz, you could have one problem similar to this, and you should know how to do it. You will have a homework problem, as a matter of fact, that you know you have to do that. Okay? Any question on this? All right. Now, what happened here is this. We are adding these. Okay, this is the forecast in the future. So we are adding these volume that I just add here, these volumes all to the existing traffic that's on the street. So what happened here is, if you add, for instance, from 4 to 3, If you add 3,000 cars to that street, obviously that street travel time will go up. It's not going to be 10 minutes anymore. So it's not going to be this 10 minutes because you add 3,000 cars and that create congestion. So if you add 2,075 or 2,025 from 3 to 4, this 6 minutes is going to increase. So what happens if those number changes? All these threes that we did is going to be different. So then we have to redo this problem again until it balances. So what happened here? Let's say you are using a street to come to school, a minimum travel time path. So everyone figure out to use that street to come. Well, when you're adding 3,000 cars to that street, that's not going to be minimum travel time path. So what do you guys do? You change it to another street because you say, oh, this one takes too long. I'm going to go to the next block. Use that street. Some other people come with you and do the same thing. Then that street gets crowded. Then a bunch of them bounce back to the old one. And a bunch of them go to other places. So it happens until it balances that people think that, well, they cannot get a better choice. So they have to do that. So this is the same story here. If you're adding too many cars to one street, the travel time goes up. When the travel time goes up, people switch to other streets. And when they do that, all these trees are going to change. So what do? We have a method that says we use capacity restraint model. And that capacity restraint model what does it do? Well, the capacity restraint model is try to balance it. So the capacity restraint model formula is T equal to T0 times 1 plus 0.15 V over C ratio to the power of 4. This is in your book, page 282, where T, okay, or 290, yeah, maybe. The T is the balance, travel time. And T0 is the free flow, travel time. Free flow means that there are not many cars on the roadway. And V is the assigned volume, which we just have at, like 3,000 we just talked about. And C is the capacity. So what we do is for each link, so for instance, we had the 10 minutes link from 3 to 4, if you remember from the last page. And we assigned a volume of 3,000, correct? We added the volume of, no, we added a volume of 2075, correct?
Yeah.
2075. So to get the new travel time, T, we put here 10 minutes, and we put here 2075, Now, the only thing we don't know is the capacity. Depends on how many lanes it has. Capacity we have to calculate, but overall, if there's the thing, we can just use 1,600 vehicle per hour. If it's 2 lane, then will be what? 3,200, correct? So we put 3,200. If there's 2 lane, if 3 lane, 4,800. We calculate that, so that will be your new T. Then you put the, instead of 10, you put the new T. So you have to do it for each link. Find all the new travel time and try that problem for second iteration again. Until you stop when the trees do not change. For instance, when I had this tree that was like this, if that doesn't change with the new travel time, and this doesn't change with new travel time, all of them, that means that balance. So we stop right there. And whatever total volume we get, that's what the total volume would be. But if the tree changes, we have to redo every iteration. Get the new travel time and do the second iteration, third iteration, and so on. So that's what we call capacity restraint model. So you recalculate by having these, you recalculate these travel times on the links and try to figure out what would be the changes in your trees. All right, any question on that? Yeah, minute. Specific time is minute, 6 minutes, 10 minutes. Yeah. All right, any other question? So that's all or nothing assignment model. Now go back to your problem. You have a problem on page, chapter 9, the same problem, 9-4. So you have to do that problem, 9-4. Okay. Let me see if I have a picture of it. I don't know. Hold on. No, I don't have a picture of it, unfortunately. Okay, it's on page 285. And they give you okay, they give you this network. And then they have a bunch of, sub network. So this is the 1, 2, 3, 4. And they have all these numbers here. Yeah. Okay, that's the example 9-3. Okay, what you have to do is just assume that the trip table is given to you. How many trips go from one zone to another zone? And they gave you the tree. You don't have to draw you don't have to find the tree. They give you tree number 1, 2, 3, 4, and they are listed in your book. So all you have to do is just assign those trips from the table on those trees that they gave you. Add them together and then fill out the next page, which is page 286. There's a table. So there are missing links that you have to fill it out. Okay, so that's what you have to do. So read that example, and that will be your problem. And that will be your problem, which is the problem number 9-3. They say complete the assignment of interchange volume of example 9-3, table 9-2 for all links of the road network. That's page 293. So do that homework for the next time. But you have to learn how to get the minimum travel time path from 1 to 2, 1 to 3, 1 to 4. You can practice it to draw it the same way I did it with that problem. Because if I give you on the exam, I will not give you the link. So you have to do the same thing I did. Compare the minimum travel time and then do that. So do the same way I did it. And then go back and look and see if you did your 3 right. So that you get a practice. And then assign the trips. Do exactly what I did, those 3 steps. All right, any question?
Professor, on the capacity
Yeah.
restraint model, the
I will publish it tonight or tomorrow morning for this week.
Oh, I was just gonna say if the capacity is given.
Yeah, capacity usually, well, when you're doing on the street, you always can observe to see how many lane it is. And usually the county or city wants you to use capacity 1,600 vehicle per lane. That's pretty much standard. Although it could be 1,800, 1,900, but to be conservative, they want you to use 1,600. So if it's 2 lane, will be 3,200. If it's 3 lane, will be 4,800, and so on. So the number of lanes and the capacity will be given to you. Okay, any other question? All right. So just try to do this problem, and if you have any questions, just ask me next time. Okay, thank you guys.